Hi there. Question 3. If you've just joined this question to explain question 1 and 2, the thumbnail would have been a bit wrong, but it's because question 1 and 2 are the same on each paper for 2A, 2B, and 2C. So question 3 is the first unique paper to 2A, which is what we're looking at right now. So which of the following cannot be correct? Correct value for the product moment correlation coefficient. So just to explain, this is a measure of correlation, how well or how uniform the correlation is. So for straight lines, we'll have like +1 if it's a positive correlation and all of the plots are exactly on it. And if we're going to have them in a negative format, that could be -1 as well. And what's confusing is these two can both be -1, because if the correlation is totally so that the line of best fit or the regression line has got all of the points onto it, then that will be a perfect correlation, even if they've got different gradients. So for these, or for part A, sorry, this value here is less than 1. So that one's okay. So it's this one here that is the one that stands out because it cannot be greater than 1. So it can be between -1 and 1. Okay, for part 3B, complete the table by matching the coefficient to the letter of the correct diagram. You do not need to calculate the coefficient. So first one that stands out, we've got this value here, which is very, very nearly a perfect correlation. And it's a positive correlation. So I can rule out C. I'm ruling out B because that one's a negative correlation. So which of the two, A and D, have got the stronger correlation? Well, it's A. So we're going to put A into that one there. Okay, I then said about C having no correlation. Of the 3 values left, this one here, -0.0153, is closest to 0, 0 meaning no correlation, so I'm happy to put the answer into there. Right, now I'm left with 2. B and D, we've got a negative and a positive correlation. If I was to look here on D, I'd say we've got quite a positive correlation, so I'm quite happy with that being 0.619. And then for the last one, that will be B, and we can see that does have a negative correlation, and those points are quite close together. Okay, final part. Part C, the scatter diagram shows the correlation between the speed of the blades of a windmill and the wind speed. Bill looks at the diagram and says, increasing the speed of the blades of the windmill causes the wind speed to increase. Is Bill correct? Now, Bill doesn't have godlike powers, so he's not able to spin a windmill a bit quicker and make wind go faster. So this one is no, not correct. And to correct him, an increase, my pen has stopped working. Here we go. An increase in wind speed will make the blades go faster. There we are. Nothing can make my handwriting go faster. And that's because the wind speed is the measurable thing. It's like the input and the blade spinning is the output. So we can't change the output and hopefully make the input change because that wind speed is the thing that we're measuring. So yeah, that's question 3. Hopefully you like that I'm doing a bit of 2A and 2C, doing my best with these papers. So please, of course, like the video if you've watched it and spread the word. Subscribe to the channel, and I'll see you next time.